Welcome to Did You Know? The ESCO HVAC Show. We will see you in about 45 seconds or so. Make sure that you are subscribing to our channels, our LinkedIn, YouTube, Facebook. Turn on notifications, and we are very excited to be here with you. It's almost time, about 30 more seconds. Make sure to grab your notebook and pen so you can jot down notes along the way, because at the end of the show, you could have an opportunity to ask our guests questions so we can dive a little deeper into these topics. And here we go. Welcome to Did You Know? The ESCO HVAC Show. Well, hello, friends. Thank you for joining us once again on Did You Know? The ESCO HVAC Show. So we have a very special series to bring you, brought to you by our good friends at Regal-Rexnord. Chris Mohalley, how are you, sir?
Very good, thank you.
So we're going to spend 4 sessions together. So we're going to do 4 different months, the first Thursday, the first show of the month, and we're going to dive deeper into ECM motors. So this week, we're going to talk about ECM constant airflow motors. The following month, we're going to dive a little deeper into ECM constant torque. Then we're going to go into ECM condenser motors, and then we're going to talk about the effects of airflow on all of the different ECM motors. And you go, well, why are we diving into ECM motors? Well, for me personally, it's a great topic to talk about, because when we start understanding motors in general and the differences between like permanent split capacitor motors and DC motors and ECMs in particularly, it gives us a better understanding of technology, right? We're spending a lot of time talking about inverter technology and transitions into new generations of heat pumps. And if you have a confident understanding of ECM motors, you'll actually have a more confident understanding of inverter compressors. So Chris, thank you so much for joining us today. And let's dive a little deeper into ECM motors. And by the way, everyone that's joining us, we are truly honored to have you here in our community. So let us know where you're joining in from. I see Tom Tebby out there joining in from Louisiana. I'm here in Brownsburg, Indiana. And where are you joining us today from, Chris?
I'm in Racine, Wisconsin.
Ah, nice. How's the weather up there?
It depends on the day these days. We had snow on Halloween, and now it's 50.
You know, we actually had a little bit of snow ourselves. Not a lot, didn't stay, but yeah, definitely got pretty cool. All right, well, let's dive into, I consider you one of the motor masters of our industry, one of the lead technicians and trainers. And I always like to present that a lot of people don't understand that you can be a technician and not be a good trainer. You could be a trainer and may have never actually been a technician. But when you have the combination of the two of those, that's when the magic happens. And that's why I enjoy hearing you so much. You can speak the truth about what we see out in the field. So
thank you.
Yeah. So, all right, let's see a little bit more about constant airflow motors.
All right. So I will jump right into the presentation. Just an overview of, when we say constant airflow motors, the industry knows these motors by the term variable speed.
Yes.
And I don't like the term variable speed, but that's, once you get to know me, I have pet peeves just like everybody else. And
Right.
Variable speed's one of them, because if you take a single speed motor and you change its load point, its speed changes. So every motor is variable speed if you go by that definition.
Oh, absolutely.
So the reason I like the term that our engineers gave this motor way back when, constant airflow, is if you really just focus on the words, it's a constant airflow motor. It's kind of like if you focus on the words cruise control on your car.
Right.
When I set the cruise control, it maintains 70 miles an hour. When I have a constant airflow motor, I might be maintaining airflow, and that's exactly what the motor does. So you kind of get a better understanding of what the motor does when you think of when you listen to the words constant airflow, constant torque, constant speed. And so we'll start off with the constant airflow motor in this session, as you said.
Yeah.
I do like to, for people that are maybe not as familiar with these motors, to know why. Being that it is our premium level product, it's typically found in your premium level HVAC equipment. So your 2-stage, which entered the industry back in the late 80s, same time ECMs entered the industry.
Right. Wait, what? 1980s?
Yeah, the late 80s. I may or may not have had a mullet back then.
Oh yeah.
Uh, I wish I still had some of that hair. So yeah, late 80s with 2-stage, and then that obviously progressed into 3-stage, and now we have modulating, systems. That's where you're going to find the constant airflow variable speed motors. Not so much in your single stage equipment, and not so much in your not really at all in your builder's grade level,
Right.
low level equipment. So what if you don't sell premium level systems, or you don't work on premium level systems, or a lot of them, you may not be as familiar with these motors
Exactly.
as others. So I like to cover that early on. These motors are also what I like to call communicating, and I like that word because
Mm,
it immediately says something different than multi-tap, multi-speed.
absolutely, it does.
You're not going to be moving wires from one tap to another to change the speed of the motor. You're going to be doing something else, because the motor is actually communicated with information from the OEM control board to the motor, which dictates how the motor performs. So
Absolutely.
to change the performance of the motor, you're going to be adjusting dip switches or jumper pins, or lately many manufacturers are moving to the fully communicated system, where
Hmm.
the thermostat's communicated and all the menu selections and even fault codes are at the thermostat.
Absolutely. And we've talked about that quite a bit on the communicating systems, that we're typically using a variable 5-volt DC signal. So it's not like a light switch of 24-volt AC. Like if you think
Right.
about it like a standard thermostat or a PSC motor or a single or two-stage compressor, we're talking about a switch that applies voltage so that we have a load on something. When we talk about communicating, now we're talking about variable signals, just like we're talking about an internet connection. Any type of a serial signal where we use variable inputs and outputs, like all of our inverters are using pressure transducers and temperature thermistors, typically all from a 5-volt DC signal. A lot of our communicating thermostats. And on that 5-volt DC signal, we teach, well, we're not here to learn how to read the command that's going through it. We're learning to read that there is a command, that
Right.
there is something happening there. And so that same principle applies when we get into ECM motors. And when we understand that, you can look at a motor now and be able to go, well, hopefully by the end of this class, you're going to look at that motor and you go, that makes so much sense now.
Yeah.
And yeah, this is a fun topic.
Yeah, that's my hope. And actually, I'll kind of give away the presents early. In my opinion, these motors are actually easier to work on than
Super easy.
induction motors,
Heck yeah.
because there's really only a couple of inputs and outputs to check. And when we get to the point of understanding that an ECM is a motor that's operated by a control, and
Hmm.
that control is a circuit board, microprocessor, whatever. And I'm sure you've taught this or had somebody on your show that's taught this. Any control, diagnostics is just what's the input, what's the output,
That's
and
it.
once you understand that, it becomes real easy. So
Yeah.
the last bullet point I did want to mention before we move on is the constant airflow programming. Each of these motors actually has a constant airflow algorithm, because that algorithm has to understand airflow
Pressure.
in CFM, has to
Hmm.
understand static pressure, and it has to correlate that to torque and speed in the motor. And we're not going to dive that deep into the motor in
Sure.
this particular show. I mean, we could, but that would be a whole
No,
show unto
1,000 foot
itself.
to 100 foot would be good, because that way every technician, every instructor knows, okay, I didn't know much before, so we started here
Right.
and I got to here where I understand exactly. I'm not going to be an engineer. I don't need to know the
Right.
100 foot down into the algorithms. But if we wanted to go deeper, let me know in an email. Let us know in the chat. Maybe some other episode will dive deeper into algorithms and what those inputs look like to dictate the output. But for the most part, we're talking about troubleshooting and understanding how these things operate. And that we're definitely going to be able to do today.
Yeah, and the main reason I like to bring that bullet point up is, so I get asked quite often, can I take a ECM from a carrier, and it looks the same, has the
Right.
same
Looks
plugs, and put it in a train?
right.
And I've even had people tell me, well, I've done that and it works. So what do you think about that?
Mm,
Because they'll hear me say, no, you can't
got
do that.
lucky.
Yeah, well, it may be running, but is it running at the right airflow? Because
Exactly. What the equipment is demanding or needs.
right, because that might be like taking the computer chip out of a
Yeah.
Chevy and putting it at a Ford. Well, if they were both V8s, it might fire the system, the motor up. But is
Exactly.
it running at the right
Correct
horsepower? Is it running at the
timing
right
and
oxygen levels? Blah blah blah.
absolutely.
So you need to understand that these motors are actually engineered not just by us, but also by the end user, which, my end user is the HVAC manufacturer,
Yeah.
engineered by them to match the performance of each system that they go into.
And some of those manufacturers have algorithms that work opposing from each other. So even if something happened to run when you get a call for G, as the speed is demanded to increase, the algorithms could actually be calculating the opposite direction and slowing a motor down. But
Yes.
that's a whole nother story. So
Yeah.
it's crucial that we're matching the correct program. And it actually comes down to even model of the furnace, because
Yes.
the same model series of furnace, I need different airflows for a 60,000 upflow and downflow,
Right.
80,000, 90. So it's very specific for the actual controlling to get that airflow.
You bet. And you just covered one of my slides coming up. So nice,
Uh-oh,
nice,
oh,
nice lead
backtrack.
in. No, I like lead in. So they're good. So just to take a little step deeper into what is communicated means,
Yeah.
our motors, and so the first motor we ever built, and when I say we, the ECM technology was introduced by General Electric back in
Yep.
the late 80s. We acquired the 48 frame motor business from General Electric, including induction and ECM, in 2004-ish,
Mm,
rebranded it under Gentech. So that's why I keep saying we, even though it wasn't we.
right.
Kind of what is that saying? The royal we's?
Yeah. The
Uh,
company.
I don't even know what that saying means. But if you go back to even the early 90s, all of our constant airflow variable speed motors have two plugs. They've got a line voltage plug and they've got a communication plug. And actually, from the early 90s all the way to today, there's really only two different motors. There's motors with a 5-pin line voltage plug and a 16-pin communication plug. And then you've got motors with a 5-pin line voltage plug and a 4-pin communication plug. And I'll warn you, here's one of my really bad jokes. What's the difference between the 16-pin motor and the 4-pin motor? 12 pins.
Yeah,
I
not
told you it
much.
was going to be bad. I told you they're not good jokes. So, but the difference in all sincerity is the type of communication, right? So,
Yes.
and anyone that's been to my class has heard me refer to these motors like printers. I use printer analogy: computer, printer, motor, OEM board, right? So,
Yeah.
if anyone that's listening had a printer 15 years ago, right? You remember that the cable between the computer and the printer was a
Hmm.
very wide cable called
Yep.
parallel port, I believe. A lot of
Ooh.
pins in there, easy to bend them, not get them in the right place, right?
Yep.
That was the technology of the time, early 90s, when those 16-pin motors were designed.
Absolutely.
And I get asked often, well, why do you still make them then? I mean, the printers don't use that technology anymore. Well, we keep making the motor because the manufacturers
Manufacturers
they
still
keep
carry it.
asking for it, right? So,
Absolutely.
but we did introduce the 4-pin motor, which is akin to a USB port. If you
Yep.
ever look at and I think I might have one here. If you ever look at one of your USB plugins, I know you can't see that, but if you look at your USB plug-in, inside there are 4 pins, and those 4 pins are communicate, transmit, power, and common. So when you want to communicate with something, you really only need 2 wires. So for the OEM board to talk to the motor, I only need 2 wires to come in and send information to the motor.
Yep.
But if I want the motor to provide communication back, I'm running, I'm here, what
Something.
speed I'm running,
Yeah.
then I need a transmit channel back. So that's how the current 4-pin motor works. So when you look at the 4-pin motor, again, trying to make things simpler in your minds, not those
Yeah.
big scary ECMs.
That's right.
Just think about a motor with a 5-pin plug and a USB port, because that's really all that 4-pin plug is.
Yeah, absolutely. Well, and like when we talk about things like pressure transducers on a inverter system, or even your pressure transducer that is on your digital manifold gauges, we've got a hot, we got a common, and then we have a variable coming back. So when we start getting into serial communications, that's typically what we're talking about. Is we're talking about supplying a constant and returning some kind of a variable so that
Yep.
we can talk both ways. Sometimes we have the extra where we can variable forward and variable backward. We're just talking back and forth on a simple wired connection.
Yes, sir. And a little later, we'll talk about what some of those voltages are, because obviously you're not going to have an oscilloscope or a device
Right.
that can actually read that binary code.
Yeah.
But you can measure most of that communication with either AC or DC voltage settings on your meter.
Nice. All
Yeah,
right.
yeah. So what does the communication do? The communication is the on-off command for the motor. The line voltage to an ECM is connected continuously.
Yeah.
And we do that on purpose. And I didn't take my motor apart, but I'll do it while I'm talking. Do you have one taken apart there?
Yeah, absolutely. Let's say, Daniel, we'll throw that
You
camera
got the
feed up
control
here.
off already?
Yeah,
Okay.
no, but I'll do that
No,
while
you
we're
got one
talking
right there
here.
next to you. You got a control.
Yeah. So we got
So
those.
if you look at that control that's next to you there, inside, you're going to see some little capacitors. Look at those cute little guys. Aren't they adorable?
Mm-hmm.
Those capacitors are about 1,000 microfarads apiece.
Mm-hmm.
So they carry a punch. So the reason I bring this up is I get asked all the time, why is the motor continuously powered? Why not switch the line voltage on and off instead of switching the communication?
Sure.
And it's because of those capacitors. Every time the line voltage is turned off, the caps discharge.
Discharge, it takes a while.
Every time you turn the motor back on, they have to fully charge, and they draw a significant inrush of power to do that.
Okay.
So we leave, and that would cause the manufacturer's circuit board to have a more robust relay if we were to be turning that line voltage on and off. So
absolutely, controlling that load, that inrush load. Yeah.
Exactly. So we leave the motor powered all the time, and again, relating it to something like the printer or even your home stereo, or I mean, do you unplug your microwave when you're done working it?
No, it stays energized all the time.
You press the on-off button, and that sends the command to the devices to turn on and off. So that's why we do it that way, and the communication controls that. But it also controls the communication, also controls the airflow the motor is going to operate at. So if the dip switches, you can see the square around the circuit board on the screen. If the dip switches are not set correctly, even though the motor might turn on, it might not be producing the right airflow. And the only way to adjust that is to change the communication coming to the motor.
Right.
Because I have been asked, so what if I take the wires out of the 16 pin and move them around? Well, usually that's going to cause the motor to not run because you've rearranged the communication, and it's not going to like that.
Right.
So it's not a tapped motor. You're not going to change speeds by adjusting the wires.
Exactly.
You're going to adjust the dip switches on that board on the screen, which is going to change the communication coming to the motor.
Sure, it's going to change the voltage or the pulse width modulation of that voltage so that it gets an idea what the command is.
Or the serial communication if we're talking about the 4-pin motor. Exactly. Yep. Oh, go ahead.
One question that just came in, and I think I'll try to clarify that real quick. Is it worth replacing a bad resistor from the module? Well, we definitely don't do repairs on the modules. There was a time, a long, long time ago, if you had an MOV go bad, which a lot of people don't understand what that is. So we're talking about metal oxide varistor. So it is your surge protection that comes in off from our actual mod. And there was a time where that was a serviceable component. Those days have changed. We are now fully epoxied through the entire control. And so it has become a non-serviceable component. At least from my perspective. I don't know if the OEMs have a different perspective on that, but that is definitely where I ended up as a technician, was that those days of servicing are actually gone.
Yeah, it was never meant to be a serviceable component.
No.
A company not authorized by us came up with that part, packaged it, and sold it. And there's a lot of liability when you do something like that. You basically remanufactured that part, and now if something ever happens in that home,
you're liable.
You will be held liable for it. Gentech will not, or even Carrier won't be held liable just to pick an OEM. They will certainly go after that technician, but also because that might not be the only component that's failed.
Right.
And I've heard a lot of technicians say, well, I buy them by the bulk and I install them and it always works. But you don't know if it's going to keep working or what other components may have been damaged or weakened in the process. Since it came up, though, I do want to mention that device that you pointed at is actually an NTC inrush thermistor, negative temperature coefficient inrush thermistor, and its job is only to prevent a inrush when the motor is turned off by line voltage. So take the door off, close the unit disconnect. You're going to take all the line voltage off the motor. The caps are going to completely discharge. And then the next time you turn it on, those caps are going to want to charge. Right there, you've got a half-horse module. That's 2,000 mics a cap that are going to want to charge up all at once. So that NTC inrush thermistor's job is just to slow that current down for a millisecond so that we don't, pop the main breaker every time somebody resets the power or takes the door on and off.
Sure.
So the reason I explain that, to your point, not information just for the sake of information, if you see that device failed, that's an indication that this motor's seen a lot of current.
Excess.
And that excess current could be because the airflow was set too high and it was never set properly for the system, or it could be that the static pressure in the system is so high that the constant airflow motor has been working its off, trying to maintain that airflow and to the detriment of itself. So it is an indicator that there is a problem that needs to be fixed, and just replacing that component isn't solving the problem. It's just putting the Band-Aid on the component.
Absolutely.
So great question, by the way. I appreciate you bringing it up.
Yeah, definitely.
The last bullet point I did want to touch, and where I think we're going to get it on the next page as well, is you are going to need the OEM manuals to adjust airflow. How do I say this properly? Unlike popular belief, HVAC systems don't come from the manufacturer perfectly set up for every home they're going to go into. Yeah, I know. It's a surprise.
They're a drop and go package, aren't they?
Plug and play, right? You just plug them in and they play.
These things are so smart, I don't have to do anything. These new variable technologies and communicating thermostats, I just hook them up and go.
They are getting smarter, especially the ones with communicating thermostats. The thermostat can talk to the outdoor unit and actually set that airflow. But you will need the manual for some of the settings. Back in my day, and I know you can see the blurred out books behind me, I carried books and books and books to have the manuals. Today, you're going to get them all on your phone. You're going to Google a model number and probably find it. But become that technician. Sorry to take a segue
No,
here,
absolutely.
but, please become that technician that on every job pulls up the manual and checks to see if the system has ever been set up properly and measures the airflow. You will just be amazed at how much better systems will run, how many fewer repairs you have. Customers that'll tell you, I never knew that the air coming out of that furnace could be warm. I thought it was always, it's a high efficiency. Right. They told me
high
it would be cold.
High everything.
With one dip switch setting, all of a sudden, hey, that feels good. So there's my punch for the industry.
No, absolutely. I seen it so much when I was doing technical support calls that I would do site visits. First the call is, all right, let's verify that we got proper airflow. Oh yeah, I got proper airflow. And the most common call that I had on my constant airflow motors is that they were tripping out on blower fault codes. And the beauty of the communicating system is that it can send a signal back to the control board when it senses high temperatures. And where do those high temperatures come from? Well, they come from excessive load on the motor. And it is almost every time I would find excessive static pressures. And we'll dive into that later on, probably episode 4, when we get into how airflow affects them. But we always have to remember that a motor is a motor, and excessive pressures are always going to have negative consequences. So they can fix themselves a little bit, they can tweak, but they definitely can't fix bad habits.
Yep. And we will touch on that just a little bit here for those of you that are going, I was really hoping they'd talk about that today. We will talk about it.
You got to come back for more. Got to tell all your friends too.
We'll tease them, yes. So, a big part of the setup is simply the cooling and heating airflow. Those have to be set correctly. Beyond that, everything else is creature comfort. But these systems truly do have some pretty amazing creature comfort abilities now, and not just comfort, but even I live in Wisconsin, right? High humidity for us is when the windshields are wet in the morning and we freak out because the dew points are high. And for those of you in Louisiana or other humid markets, you just laugh at us because that's your wintertime conditions, my peak summer. But there are truly some amazing features on these new systems that can adjust the not only the amount of air, but the time that the airflow runs at certain levels to get more latent versus sensible removal out of the coil during a typical cooling call. So besides the fact you can have first stage, second stage, you can also then have a first stage and second stage that are running at part airflow for a certain amount of time and get more latent removal. And then, of course, because the manufacturer has engineered all this in, you can get all that without having to worry about freezing the coil by just dropping a speed. And so those are all the other functions there. Some some of them are simple selections where you say, hey, I want more dehumidification, or some of them are more sophisticated where you can pick a profile that matches your market. And some of them are even more sophisticated where the unit will look at the humidistat or humidity sensor
That's right.
in the thermostat on the wall, and it will gauge whether it needs to go into dehum mode by what's actually happening to the conditions in the home.
Boy, that's a
Um,
whole nother topic. That could be a fifth conversation right there, because I can preach
you,
all day long on proper airflow for dehumidification, especially when it comes to inverter operation. So, yeah, we
and
want
we
to
would
go
need to
there.
bring in Rick Kinsel for that one,
Okay.
so because he's the expert on that. But yeah, but so the thing to keep in mind is it's not the cooling and heating airflow are not always going to be properly set up for every job the unit goes
Right.
into, but all of those other settings, the creature comforts and the dehumidification, they're going to be set at a default setting for for general USA, not for
Different
Fargo,
climate.
North Dakota compared to Miami,
Yeah.
Florida, which are going to be drastically different climates. So you'd have to go in and adjust those. And my plug as a former technician, maintenance technician, service technician is, this customer paid for a premium level system. They're not getting a premium
Oh,
level
man.
system
Yeah.
if we don't set it up properly. And each job is
Yeah.
different. I mean, even here in Wisconsin, I would set up systems for maximum dehumidification. You go, why in Wisconsin? Well, I've got a family that never opens the
Hmm.
windows. They're asthmatic,
Hmm.
whatever. The windows are always going to
That's
be
what they're looking
closed.
for.
There's multiple people living in the
Mhm.
house. Maybe they're and I hope I don't get in trouble for this. Maybe they're Italian and they cook a
Right.
lot. I'm
No, it makes
and
sense. There's
so
a lot more
there's going to be
contaminants
a
in the
lot of
air.
moisture
Yeah.
in the house and a lot of showers in that
Hmm.
house, and I want to get that humidity out of the house. So there are reasons to set those settings not only based on region but also
By
by
design.
the consumer's preferences.
Absolutely. I
Yep.
had a friend of mine do his own general construction on a new home and built it as encapsulated as possible. And come Thanksgiving, my first call was, "Hey, I got sweat on every single window in this house." And I said, "Yes, you do."
Yeah.
I know it's not
And that's
Florida.
a whole nother
That is
show.
another show.
So let's talk about those settings. And I'm going to refer to dip switches. They are the most popular type of control that manufacturers use. But as I mentioned, some still use the jumper pins,
Right.
and some are using the fully integrated thermostats where they can make the selections at the thermostat. But what you'll find interesting if you're a manual hound like I am, is you'll recognize things like in a lot of the charts. There's a little
Yeah.
dot next to one of the airflows.
Yep.
And I'm sure you know what that dot means.
Yeah. That's just factory setting.
That's the factory
Yep.
setting. So that's where the airflow is going to be from the factory, which is perfectly fine on this two-stage gas
With
furnace
a 3-ton
as
air
long as I'm
conditioner.
installing it with a
The
3-ton
most
air.
common one, which is why they pick it, but is it
There
always
you
that
go.
way? Well, no, there's a lot of different selections. Back again, depends on what part of the country you're connecting this to. It could be a 2-ton, it could be a
Exactly.
5-ton.
Right. So if it is a 2-ton, what we need to understand is if I don't change that selection, that motor is going to try to make 1200 CFM of
Absolutely.
air, no matter what size the ductwork is. And so here's your first your first real good laugh of the show, right? So assuming that house had perfect ductwork, insert laugh here. If it's only 2-ton worth of ductwork, right? So it's only 800
Yeah,
CFM
yeah,
sized ductwork. If it were
right.
perfect, that motor is going to try and push 1200 CFM through it. So it's going to be working
Yep,
harder. We talked about that in that thermistor failure. What it's an implication of? It's an implication of the motor working hard. That dip switch, and if we look very carefully, I'm going to show you. It would be one switch. Is all I have to move, one switch, and I have perfect airflow.
wow.
And it's just that simple. So I could have not only customers complaining that, gee, the system's really loud. If I'm set at 3-ton, maybe I'm not getting very good dehumidification. And boy, I lost the motor at 7 years. That doesn't seem to make sense.
Exactly.
All because of one dip. And I see I'm pointing at my other
Right.
screen. Sorry about that. All because of one dip
Yeah,
switch.
yeah. No, and unfortunately, it's a very common mistake to not be
Yeah.
commissioned properly. We see it all
Yep.
the time where in that exact case right there, the call would be, "Hey, I've got blower fault codes on this communicating thermostat." And you go, "Well, what is the blower trying to do?" That's what it's telling you. It's trying to do something. And many a
Right.
times it's exceeding its temperature because it's trying to move more air than it is designed. So the static pressure, and if we had an 800 CFM duct design and we're trying to push 1200 through it, we all know what's going to happen. Our motor is going to draw excessive current. It's going to see increased temperatures, and it's going to correspondingly give us hopefully a fault code. But the problem that I see from the technical support side is that most of the calls that I went to, it was literally just high static pressure because of poor setup of the dip switches. And
Yeah,
so much miscommunication or non-commissioning can be corrected with a few
better.
basic steps.
There you go. There you go. So on the heating side, it would make sense that this furnace would come set up properly from the factory because they know what BTU it is. Well,
Absolutely.
that's true, but as I mentioned before, you're going to take out a 70% efficient Chrysler air temp that had a temperature rise of 70 to 100 degrees, and you're going to put in a 95% two-stage that has a temperature rise of 35 to 65. The customer is going to complain, boy, that air is a little cool,
Absolutely.
especially in first stage. And where, again, here, if I flip one dip switch, I can actually get, what is it? My
Go from
math, I'm not
43 to
good at 8
51 temperature rise.
degrees.
Yeah.
I can get 8 degrees more temperature,
Mhm.
and I'm sure, that everyone knows the human body can recognize a 1 to 2 degree temperature
Absolutely.
difference. That's going to be a big difference to that consumer in that home.
And still well within
And
the
that's
temperature rise range.
well within the temperature rise, not even at the top end
Yeah.
of the range. Absolutely. And being that it's a constant airflow motor, I really shouldn't have to worry about setting that temperature rise higher. I
Mhm.
know back when I was a technician 30 some years ago, when PSC motors were the primary indoor blower motor, we set them in the middle of the
Yeah.
range because PSC motors lose airflow when the
Filter
static
gets
pressure
too
goes
weak.
up.
Mhm.
And I had to basically set up the system as middle of the road
Cushion.
because the customer might not change the filter. They might close a register, will close the register, and that's going to force my static to go up. And
Yeah.
I needed that buffer in the temperature rise, but
100%.
I don't need to plan for that with a constant airflow motor if everything is set up correctly.
Correct. Okay.
So now the teaser, the little bit of the static pressure information. So they're programmed to adjust and maintain airflow irregardless of static pressure. Would you agree to that statement?
Absolutely.
Okay. Unlimitedly.
Until it
I don't.
overheats.
Well, actually, no. Actually, our motors have what's called a speed limit. And again, I'll use your own
Yeah.
car as long as you're driving something that's less than 10 years old as an analogy. If you put your own car in drive or neutral and try and rev the engine, you're going to notice your engine's going to start stalling out at around 1500 RPM.
Mhm.
They've got speed limits on your
Sure.
system. So if you on your car, so if you were like me in the 80s and you had an inline six Ford
Yes.
Maverick
Absolutely.
and you
Lots
wanted
of
to
good motor.
squeal the tires, you did a neutral
That's
drop.
right.
You'd rev that in.
Get the
Well,
RPMs
you
up
can't
first.
you can't do that anymore. So the motors are the same way. They have a speed limit built into them, and the speed limit's going to be based on static pressure.
Mm,
So does the motor know static pressure? No, but it knows how fast it's running.
exactly.
So we let the manufacturer of the appliance dictate where that speed limit kicks
Okay.
in. And so everybody always asks me, well, when's that speed limit going to kick in? And I say, look at the charts. If the OEM chart says doesn't give you data past 0.9, and by the way, if this were an OEM manual, right below those charts, it would say, do not exceed total external static pressure listed on this
Oh
page.
boy.
That's because that's where it's going to begin to run into that speed limit. And
Okay.
when the motor runs into its speed limit, it is going to decrease torque to maintain speed at that maximum, whatever that maximum value
Right.
is. And at that point, this is no longer a constant airflow motor because it's in self-preservation mode.
Yes. And that's the
And
important
so,
part to understand.
yeah,
It's trying to protect itself.
yes. Yeah, so you can actually have a constant airflow motor that has a frozen
Yeah.
coil or tripped limit, and if that's the case, it's going to be either one of two things: either your static pressure is horrendous, I should say, could be, or your dip switches are set improperly, possibly as well.
Nice.
So we need to understand that one, if you look at the chart on the screen, the constant airflow motors on the bottom, PSC motors on the top. Everyone knows that when static pressure goes up, PSC motors underperform, for
Yep.
lack of a better description.
Absolutely.
They provide less airflow, and we can see from the ECM on the bottom that we're maintaining airflow all the way out to 0.9.
So how do we do that?
Well, there again, the motor doesn't know what static pressure
No.
is, and it doesn't know what CFM is, but it has and this is where we won't go too
Mhm.
deep, but it does have an algorithm programmed in the motor by each manufacturer for each appliance, where it knows the relationship between static, CFM, torque, and speed.
Yes.
So once it's taught those 4 points, the motor's simply monitoring torque and speed, because it can monitor its own power consumption. And we use the permanent magnet rotor as our Hall effect sensor, so we don't need a Hall effect sensor.
That's right.
The rotor gives us our own feedback
signal.
to give us rotor positioning and RPM. So we can monitor all of that, and we can set that airflow based on those parameters. But I think it's, a couple of things are important to understand. We already touched on one of them. One, if you exceed the total static as listed in the manual of the system, you could start producing less airflow than what the dip switches are set for.
Absolutely.
That is a very real possibility with a constant airflow motor. Two, just because this chart says I can make 1200 CFM at 0.9 doesn't mean you want to run it at 0.9 24 hours a day.
Yeah, something's going to fail.
Correct. These motors were designed to be set up at a midpoint, so around 0.5, 0.6, 0.7, with a clean filter, registers open, properly sized ductwork. And the idea was, as the filter got dirty, the motor could ramp up and maintain airflow. And then when somebody cleaned the filter, we'd bring the static back to design, and that's the way we'd run. And I like analogies. Living in a fairly flat state in the Midwest, it's like I set the cruise control on my car to 70. I go up and over overpasses, no problem. My cruise control can handle that. But if I was in one of the Carolinas heading up one of the mountains, I'd be an idiot to leave my cruise control on, because eventually the engine would start downshifting,
and our RPMs are going to go up.
I'd be working the motor really hard. So that's the point of the explanation about the correlation between the static pressure and what the motor can and what it can't do. Can it make 1200 CFM at 0.9 as that chart says? Absolutely. Can it do it indefinitely? No. And I get asked, what's indefinitely? Well, 5 to 7 years is probably going to be a long life for a motor that's been set up with the dip switches set too high, or the static pressure near its maximum. And that's not a number that I got from my engineers. It's not a number that I got that number from 20 years of training ECM and tech support. And hearing, I lose motors at 5 to 7 years. Why? And then my first question is, well, where are your dip switches set? Then the answer is, what the dip switch? But I need a rim shot from your producer there. Thank you.
I used to threaten my dealers with this right here. If my static pressure on an installation is outside of my manufacturer's recommendations, I could potentially void a warranty on a product because it was improperly installed. The manufacturer says it is only capable of this. Not to say that it would ever do that, but I would threaten my contractor so that they understood that previously, if you had a external static pressure chart and you knew that you're getting to the high end, you knew that if it got any higher, it was going to start diminishing airflow even more drastic than it had before. With all of our ECM motors, that range is because we know we get outside of that range, we get above that range, and we are going to have consequences. I've seen manufacturers set consequences as detailed as blower fault codes, so that once it reaches that point, it is going to go into self-preservation mode. And the contractors go, well, why is it doing it? And I said, well, why wouldn't it? It's smart enough to protect itself, and it's trying. It's trying to overcome improper installations or failures within ductwork or things that have been changed on the system. So it's very critical to know the capabilities of that motor. It's not going to run forever. It's not going to overcome. I keep hearing constant airflow motors will overcome static pressure. Well, they'll try for a little while in a window.
My favorite is, if you have bad ductwork, install a variable speed motor. That's my favorite misnomer.
I wish I had $1 for every time I heard that one.
So no, all good points, and it brings us up to the next slide, which is where the numbers start to make even more sense when I bring in the amperage and the wattage.
Oh, there we go.
And now you see the constant airflow motor. Yes, it can make 1200 CFM at 0.9.
Boy.
But it's 2 amps higher than it is at 0.5.
That's a lot of extra juice.
It's a lot of extra juice. And, it's funny because technicians would often say to me, well, I don't know what the static pressure of an existing ductwork is when I install a new system. So how can I tell the customer until after I install the system whether they're going to need upgrades? And I actually had a couple of contractors tell me that they build that into their estimate. That they're, if the system they're replacing has a working motor,
Yeah,
they would run that
absolutely.
motor, measure the
Yep.
static, and then recommend ductwork based on the static pressure. But if it didn't have a running motor, they would build into the quote, when we install the new system, we're going to run the system and measure your total static. If it's above X, whatever they choose that number is, then we're going to recommend duct modifications. If you don't choose the duct modifications, we're not going to give you our extended
Extended
warranty.
warranties,
I
100%.
can't take away the factory
Right, it's still
warranty,
there.
but we're not going to extend that warranty the way we normally would, because you're not allowing us to build the system within the parameters that allow it to live the design life.
Wonderful, honest business model.
Yeah,
I've
that's
seen
what
that
I thought
before,
too.
and I absolutely love
I
that.
wish I'd thought of
Yeah.
it. So yeah, I like this screen
Yeah.
because it shows, bringing in the watts and the amps. It really brings home why I'm preaching that you can't just run these motors at 0.9, and why on every job you really do need to be measuring the static pressure. You're not doing a customer service if you're not measuring the static pressure.
Absolutely. It tells so much about the system. And I hope that that is one of the big takeaways, that our technicians in particular, that are watching this and they recognize that and they go, wow, I know that I probably should be checking static pressure just on a service, but maybe I need to implement this on every single call. I actually had a technician, a young technician, a hungry technician. You get that one every once in a while.
I love those
They're
guys,
just
or gals.
so hungry. They're like, oh my gosh, I can't believe that. Is it really this bad? And so I challenged this one technician. I said, I tell you what, when you go out in the field, you start adding an extra 12 to 15 minutes. That's all that it takes. Add that on as part of your service call. Right. Add that on and let's see how much ductwork jobs you get out of that. And 6 months later, the young fella came back, and a year and a half before, he was new into the service industry. He'd been in the installation, but he was new into the service. So in that short period of time, he became a lead service technician,
Of course,
because
yeah,
he was finally realizing that bulb not only went off, but that bulb grew into a hot air balloon
yeah,
because he realized the problem that we have with static pressure in our industry. And some of our motors, particularly those PSCs, would allow you to get by maybe, but now with our newer technologies, we're starting to recognize those situations, and they can cause detrimental motor failures that
right,
motors are more expensive. So we'll hear that every once in a
right,
while, man, these ECMs don't last. And my response is, ECMs are phenomenal. Your installation doesn't last. And it
yeah,
makes us rethink about our role in the job. So as service
sure.
technicians, we completely have the opportunity to reevaluate the commissioning and installation of systems.
Yeah, yeah, and I hate to draw this out even a little further, but I have to,
Hmm.
because I get asked quite often, well, why make a motor that can maintain airflow if it can only last 5 to 7 years? And of course, we've had the discussion about the dip
Yeah.
switches and the static pressure, but you guys should make it more robust and it should last longer. And why can't you make it as robust as the PSC motor? And if you look at the chart,
Hmm.
and I'll get rid of some of the noise so it's easier. I guess we want the amps in there too. If you look at the chart, the PSC motor at high static loses airflow, but it actually decreases amperage.
Right.
It's doing less
Less work.
work. So the motor was not more
Hmm.
robust. We actually gave it less work to do at
Exactly.
higher static, and it said, "Okay,
I'm
I'll do
fine.
less
Yeah.
work." So the motor lasted longer, but what failed?
The compressor.
The compressor, the heat
The heat
exchanger.
exchanger.
So,
Absolutely.
so yeah. It wasn't like the good old days when motors didn't
Yeah.
fail. Yeah, the good old days when the motor didn't fail, but we had to change out compressors and heat
Oh, what a
exchangers,
great
right?
analogy.
So
Absolutely. What do you want to
had to
change?
throw that one in there. Thank you.
Do you want to measure static pressure, or you want to change compressors and heat exchangers?
Exactly. So as I said, we covered
Yeah.
airflow a little bit there. We'll cover it even more in the session you've got coming
Hmm.
up. But let's transition over to
Oh,
diagnostics.
yeah.
So diagnostics for these motors is actually, again, you heard me say it earlier, I think they're easier than induction motors.
Absolutely.
All we have to do is check the line voltage and the communication.
Yeah.
If we have both, the motor should be operating. And I will say that we do have a tool for our motors called the Tech Inspect.
Love it.
It is what a lot of people call a go, no
Yeah.
go. You're not really measuring anything. You're going to plug it in, flip a switch,
See if it
and
turns.
you expect the device to work. If it works, it's good. If it doesn't, it's bad. Go, no
Hmm.
go. And you can find the information about that on our website, regalmmu.com, and in our app, the Dealer Tool Belt. And all that information is free,
Yeah.
but obviously you have to buy the tool.
Sure.
Tool's not free,
And
sorry.
it's not very expensive.
It is not
No.
bad compared to the amount of these motors that are out there and how expensive it is to make the wrong diagnostic decision.
Yeah. You spend a half an hour not properly checking it, and you've pretty well paid for a tool.
Yeah. I spent, I would say, at least a good part of my early career diagnosing ECM motors before those tools existed and before the tech support people like myself really knew how to help you diagnose them.
Yeah.
So yeah, I wish they were available back then.
Absolutely.
So again, you're just diagnosing two things, line voltage and communication. So we'll start with the line voltage. That's on the 5-pin plug. Please do not do that. Do not take your meter and just
Cram
mash
them
those
in.
leads in the back of the plug. There's a very good chance you're going to destroy those pins, and you could create a future failure if there was not one already. Besides, and I don't know if you've ever experienced this, but I've actually experienced where I had voltage on the back of that pin, but I had no voltage on the side of the pin that touches the motor or the next device, because the pin inside
Had pushed through.
had broke or pushed through.
Yeah, I had a brand new piece of equipment that I went and did a site visit on that was verifying voltage. And I said, well, let's pull that plug off there and just check all of our pins first. And we actually found one that had actually pushed itself through. And so, yeah.
So we want to turn the power off, and we want to check the pins that touch the motor. If it's a 240 volt system, we're going to find that our 5-pin plug has a jumper wire missing. If it's a 120 volt system, we're going to find that there is a jumper wire in that 5-pin plug. And that's because these are dual voltage motors.
Right.
And I get asked all the time, well, how does it know what voltage to run at? That's all determined by the harness, which the OEM supplies.
Exactly.
So as long as the OEM didn't supply the wrong harness, you really have nothing to worry about. So if I have voltage at the motor, obviously the motor should work. If I don't have line voltage at the motor, I'm going to diagnose backwards into my HVAC system, find out where I lost it, and fix that component. The next component is the communication.
Right.
And I love this picture because it is an actual picture. If I'm being honest, it's my furnace in my home. And I have a 16-pin motor with 16 brown wires. And if you look,
non-numbered.
If you looked at this, they're not numbered, they're not color-coded, and on the schematic, there's 16 black lines that have no reference for voltage.
Absolutely.
So can you diagnose a motor without buying a special tool? Yes. But you're going to need the special manual for either diagnosing ECM or diagnosing the system by fault codes. That's how Carrier does it. I think some others do as well. Your bottom line is you're going to need a manual that's not on the job. And it might not be a manual that you can find just by Googling the model number of the appliance, because it's a special edition manual just for these systems that have variable speed motors. So without that manual, there's really no good way to do this. Now, I do also want to say, and maybe I should have gone to my shelf and pulled one off, but each OEM has done different tricks through the years for testing our motors in their systems. Lennox had a trick where you could take a 9-volt battery, solder some wires on it and connect them to certain
one
terminals.
In the van. Yeah, boy, that was. We're going back a little bit now.
We are, and I always laughed at that test because that Lennox obviously assumed, I'm not picking on Lennox, but that a technician had a good 9-volt battery. On the truck.
So true.
And because if the truck was like mine, the only 9-volt battery was the one in my meter that'd been there for a year, right?
the bad one sitting on the shelf that should have gotten recycled 6 months ago.
Yeah. And then Trane had actually a test kit where you would connect it to 24 volts RNC at the thermostat terminals and plug that in. Now, those processes worked on our motors in their systems, but you couldn't take that process or that connection and do it on our motor in another manufacturer's system because of that unique programming that we talked about earlier. Right. So that's the reason why I like to bring those up is some technicians will think, well, okay, so I've got this motor and I see that same motor in 5 different OEM systems. Why can't I do that 9-volt battery trick on every one? And it's because of that unique program.
Yeah, and some of those pins that are not being used for particular functions.
Correct. Or are being used for, they're being used, but they're being used for a different function.
Absolutely.
So, so the answer to that question is yes, you can do this, but you would need that special OEM manual. In lieu of that, if you have a go no go tool, this is literally going to be a 30-second process.
Yep.
You've already checked the line voltage plug. You've turned the power off, plugged that back in. If I didn't say so already, never disconnect the line voltage plug or reconnect it with the line voltage power on. You'll get a significant arc because of those capacitors we talked about. So power's off. We're going to take out the 16-pin harness from the OEM board. We're going to plug in our Tech Inspect. Now, if we had the 4-pin motor, it also comes with that 4-pin pigtail on it. For anyone that's watching that may have an older Tech Inspect tool, before the 4-pin motor was introduced, the Tech Inspect was produced. Actually, it was called TechMate Pro at the
absolutely.
time. It only had a 16-pin plug.
TechMate on it.
I know I have one. I should have had it here.
I did too. I'm sitting here looking at my desk going, I don't even have a plug or a harness or.
Well, I would get up, but you'd see that I'm really wearing PJs. No, I'm just kidding. But you can buy a 16 to 4-pin adapter for those older TechMate Pros. You don't have to buy a whole new tool. So you're going to connect the correct plug to the motor you're working on, and then connect the TechMate or Tech Inspect to your 24-volt power source. Transformer, and a lot of people think that on the switch here is a little green light in the switch. And a lot of people think the green light means the motor's good. Actually, the green light will come on if the switch is in the off position, as long as you're connected to 24 volts.
Yeah.
Because it's more important to prove that the device is working than to say, yes, the motor's working. Because if the motor's working, it's going to spin. We don't need a green light for that. But you know, those alligator clips are not easy to get on those little round screws on thermostat terminals. And so the green light is there to tell you, yep, you got the alligator clips on and you still got a good tool. Because if the green light's not on and you flip the switch on, all your motors are going to be failed. Not really, but because your tool's not powered. I know you caught that. It's rough when there's not an audience.
Yeah.
I have to give you.
I know. I got to be a little bit more involved here. Now we got an audience out there. Now everyone.
No, a live audience.
That's
I apologize.
Send us some thumbs up,
I can
thumbs
see them
down.
Over there. Yep. They're doing great.
You're out there.
So as long as I have the alligator clips connected and a green light on the switch, then I'm going to flip the switch to the on position. And as I've already said, and you can logically figure out, if the motor runs, it's good. If it doesn't run, it's bad. Now, this is one question that I know will come up. If it doesn't come up on the side here, somebody's thinking it, is, well, what speed is it going to run? Because I've used this on a train and the motor ran somewhat slow. I've used it on a ream or a Goodman and the motor ran really fast. Well, that's because I don't know what speed the motor's actually being turned on at. I don't know if, depending on how it's programmed, if I'm energizing the fan or the cool or the heat or the first stage or the second stage. It really doesn't matter what speed it runs at, as long as it runs. That's the key.
Because we know that we have high voltage. That's the very first step. We validated we got high voltage to the motor. Now we're applying our communication voltage. We're applying a signal to it. So if I got high voltage and I got low voltage, it should turn.
It should,
because it's probably not going to be the motor itself. You know, a lot of people don't understand how robust the actual motor itself is. I mean, we're talking about a 3-phase motor, right? We're not talking about a permanent split motor that has different resistance windings where one is almost always going to burn out before the other one. We're talking about a very, very robust motor. Honestly, I've only had one in the field that the motor windings itself were bad. And it was only because I had one winding that was more than a 10% tolerance from the others. It was like 25, 30%. I thought, well, that's out there. But the actual motor itself had not burnt out, right? They're very robust. They got good bearings to them. And so we don't do a lot of damage to the motor itself. So the go, no go is very important because it tells us really, is our mod turning on our motor? Is it giving it a command?
Correct. And I'll take that even a step further. It's not only is it a robust motor, but you have a microprocessor in front of the motor. We got a microprocessor with a speed limit. And, you know, we talked about the inrush thermistor. If that inrush thermistor fails, that's protected the motor windings from getting to a point of failure.
Sure.
So we have, just like our cars today, I use this joke, and you can gauge my humor by my jokes. When's the last time you heard any of your friends complain about throwing a piston rod or having to have the heads
That's
remilled
right.
on their
Yeah, it
car,
used to
right?
be
I
regular.
mean, yeah, that used to be a thing, but
Yeah,
now my computers and my sensors are
protecting things.
correcting things or shutting it
Yeah,
down or throwing fault codes before I get to the point of major mechanical failure. So
100%.
we've got the same thing going on here.
Oh, I seen Todd Clure out here a while ago from hvacredu.net. Todd and I are always using the automotive analogies. When we start
Yeah.
talking about the differences between automobiles and where we are for the mechanical operation of compressors, right? We really haven't changed much. Vehicles, we didn't reinvent the internal combustion engine. We made it more
No.
efficient. We give it better inputs and outputs. When we talk about our internal compression engine, which is really what our compressor is doing, it's just compressing vapors. As we advance with technology, we're not completely redesigning. We might change the vapor pump of it, but really what we're doing is we're giving it better inputs. We're giving
Yep.
it better modulation and controlling. And so the same applies to our motors, right? We still have a motor. Now we just have more advanced controls over the thing.
Yes,
So
sir.
understanding how those controls work are very important, but they're also very relevant when we think about other sectors of the mechanical world that's moved and advanced as well.
Yes, sir.
Yeah.
I like that analogy.
Buddy.
And I do use cars a lot as well.
Mm-hmm.
One other thing I do want to mention before we go past the screen, and I'm going to take this motor apart so I can hold it up to the camera
Sure.
in a minute here. So we mentioned that the 16-pin motor, actually both motors, they could run at a slow fan speed, they could run at a high cooling speed. So the speed they run is irrelevant if it's running, the motor's good. But one other piece of information that might be helpful to you is if you are putting the go-no-go on the serial communicating motor, which from our model name is 3.0 for this motor. Okay. You may experience where with the go-no-go tool, it runs backwards. And I don't get this call very often because this has also been a very robust control and motor for us because it's serial communicating,
right?
Because it can do more fault codes and tell you more conditions that are happening before they turn into failures. But when a technician does use that tool on the motor, and they experience it going backwards, then they question, well, is the motor really good? It's not running the correct direction with the go-no-go tool. And the reason for that is something we talked about earlier. This is a serial communicated motor. This motor is a slave to the OEM control
it's not
board.
sending anything back to anybody.
Well, it is actually
with the Techmate or with our test unit.
Right. But this motor actually does not know what rotation to run until the OEM board tells it to. All the 16-pin motors have the rotation value stored in the motor.
Okay.
But the serial communicated motor is told what direction to run each time it's told to turn on by the OEM board.
I didn't realize that. That makes a lot of sense. Yeah.
So if I have a opportunity to use the TechInspect on a serial communicated motor, if it runs but it runs the wrong direction, that is still a good control.
Boy, that's important to know.
Yeah. And I don't get that question very often, but which is why I forget to bring it up sometimes, but it's a good piece of information to throw out.
Yeah, nice.
All right, so we already covered the next couple of slides. If it does run with the TechInspect, then obviously the problem's not the motor or the control. The problem is somewhere from that 16-pin plug, which I obviously disconnected backwards. Could it be dirt in the plug? Could it be a loose pin? It could be. You should obviously do your due diligence and check that harness. Could it be that the board's out on a fault code, or I didn't really prove my thermostat inputs were there? Yes, you should do your due diligence, but it's probably likely that the failure is in the board that's not sending communication to the motor.
Exactly.
Right. I bring up those other things because, well, I've done a lot of training for our customers. Carrier, Train, Goodman, Ream. If I didn't mention one of the OEMs, by the way, I hope they don't hate me on this. But they don't like it when I say it's a bad board because there are other possibilities. It's likely it's a bad board, but there are other possibilities, and we we should check them before we just go ahead
Assume.
and order that
Yeah.
board.
But we're at least eliminating the control side of our motor. We're recognizing that our motor should run.
Exactly. Yep. So now to take that the other direction, if the motor does not run, then as you said earlier, we have a failed control. We know the control has failed. The motor could be failed. We don't know that unless we take the motor apart and actually ohm out the motor. And I'm going to save that one for just a little bit
Yeah, I
later.
think so.
We will talk
Right.
about that. The reason I'm going to save that is many manufacturers are selling the motor and control as one component now. Yeah, fewer and fewer are selling the control separately. But to your point, with the go no go, we've really only proved that if it doesn't run, we've really only proved that the control doesn't work. We don't know if the motor's good or bad yet. So with that said, I do want to reiterate that the Tech Inspect tool will diagnose Gentech and formerly branded GE motors going all the way back to the early 90s with the 2.0. So that covers 2.0, 2.3, Eon, and 3.0.
Wow.
So we're in our third iteration of 16-pin motors, and we're still in our first iteration of the 4-pin serial communication motor. So if you think about that, that's close to 30 years worth of motors across 7 major OEMs and all their subsidiaries. And to put a motor number count to that, that's approaching 20 million motors that we've built in that time frame.
That can all be troubleshot the similar way.
With that one tool, absolutely. Right. That's why I say I think these are even easier than induction motors.
Yeah, I do too.
I do need to say that we did make a motor. Every OEM has one little hiccup.
One oddball.
We did make an oddball. That's a good word for it. Hopefully, I don't.
No, I can say that. You don't have to.
Or agreeing it. We made a motor called the 2.5. We made it for Carrier and Bryant. And the interesting thing about this motor is it has a 16-pin plug. But if you look at the harness, and I don't have the harness here, so you don't have to close up. But if you look at the harness going to the 16-pin 2.5 motor, you're only going to see 4 wires in the harness because the 2.5 is actually a 4-wire serial communicating motor. It was our first one.
Right.
So it's kind of like we made our first Apple phone, but we put it inside of a flip phone, and just to fool you. How do you like that for an analogy? So it's a smartphone, but it's in a flip phone.
That's for the older generation.
I've actually never used that analogy, but I'm going to start to now. I like that one.
Well, they have them now.
Yeah. So what's difficult about this motor is you cannot diagnose it with the Tech Inspect.
Oh, because
and the confusing part is it's got a 16-pin. Yeah. Oh, hey, the Tech Inspect plugs in, but it can't talk to this motor. So if you do have a Carrier Bryant built between 2003 and 2008, it's the Infinity Evolution system.
Not a ton of them, but there are some.
That motor will actually hear, and you can zoom in on that if you want to, where it says 2.3, it would say 2.5. So you can look on the label for that piece of information. If you find a 2.5, cannot use the go no go. Carrier Bryant does make a tool. It's called the ECM motor simulator. I believe that's a current part number for Carrier Bryant, but they were in the third iteration when I put that into my presentation. So you would want to ask for the ECM motor simulator. And the main reason I plug this, besides the fact that it works on our motors, is those systems, those fossil fuel systems also employ an ECM draft.
Yeah, absolutely do. And those were a 16-pin also, weren't they? Or close to that?
They were actually a 9-pin.
No, I know. I remember the harness. I just don't remember how many wires was in it. But
it was a lot of wires. It was it's a draft blower. Why are there 9 wires going to it? But this box will actually diagnose those draft blowers as well. When I tell that to technicians that work on Carrier and Bryant, they're, oh, that would be nice because it's always a guessing game with that device.
Yeah, you're a Carrier Bryant, and that's a good piece to have around then.
Yes, sir. All right. So one quick thing I always like to talk about in the diagnostic section. This will only take a minute, and that is find the problem. Right. It's not enough to plug in the no-go and no-go and say, oh, it's failed. Put a new motor in. I'm an ECM champion. We need to find out why the motor failed. And part of that could be checking the dip switches, measuring the static pressure. Beyond those things, what could fail an ECM motor? Well, that's just like asking what could fail a circuit board, because this is a circuit board on the back of a motor. electrical issues or water, right? So electrical issues are surges, brownouts, transients is the word that gets
Yeah, I
used to
see that
cover
often.
everything
Yeah.
electrical that,
The whole
that
gamut of
happens that's not
electrical
supposed to happen, right?
potentials.
But the thing I will mention to technicians is simply look at the motor. This motor is fully painted except for the shaft,
Yep.
and the end shields are usually aluminum. So if the motor's been attacked by water,
Yep.
what's the most likely thing that I'm going to see that's rusted? The
Yep.
shaft. So if I have rust on the shaft, or I have rust on my through bolts, or I've even seen pictures of the motor where the plugs like had mold growing on them, you probably found the problem. There's been a lot of water attacking that motor, and we need to figure out why. Is it dripping down from somewhere? Do I have a cabinet leakage? I got a unit in an attic. I've got hot moist air leaking in the cabinet.
Exactly.
I need to find out what that problem is. But since we're talking about constant airflow motors, of the 3 items on that list, which one's going to probably be the most likely failure point?
That's a good. Let's pull some input in from those out here that are joining us today. So hop over there in your chat box wherever you're joining from and give us an idea. I can tell you what I've seen out in the
So
field, but I'd really
water,
like to know.
I think we need the Jeopardy
Yeah.
theme song going now. Is it water? Is it voltage? Or is it high static? And we could lump high static and dip switches together, because
Mm-hmm.
if the dip switches are set wrong, I'm going to have high static.
Mm-hmm.
So we got one person that says voltage.
Which I've been in an area that has some very fluctuating voltage. We also have total
Absolutely.
external static pressure. Todd's just going to cover them all just to make sure, I think.
Oh, I see a trend.
I'm seeing a trend in here. So that was
Yep.
my observation out in the field.
Yep. And here's my awesome PowerPoint skills for you. That is the biggest
Ooh.
problem, and that's why it got bigger.
Mm-hmm.
Total external static pressure, which could be either the static pressure and or the dip switches. That's going to be probably the biggest culprit. And the dip switches, again, you're probably tired of me saying that word, dip
No.
switches, but because they don't get adjusted all too often on day one, and all too often don't get checked by the maintenance or service technician, which, to be fair to them, the manual's already been thrown away, so they don't have a reference point for them. That's more than likely going to be a big part of the problem.
So
So
true.
let's talk about replacing these
Yeah,
motors.
absolutely.
So we've already talked a lot about how uniquely programmed they are,
Mm-hmm.
and that every motor is going to work differently because it came from a different OEM, and that's absolutely true. If you're going to replace this motor with a factory motor, you're going to need to go back to whatever OEM it came out of, and that sounds like a silly thing to say to people that already do the job the right way, but you wouldn't believe how many calls I get. Well, I bought it off of eBay, and it said it was for a carrier, and it doesn't seem to, it's it has to come from carrier.
Yeah.
I also get asked quite often, well, I went online and I found the 5SME39 model number, the tech model number.
Mm-hmm.
I found that motor and I bought it. How come it doesn't run? But you got to remember, I make 1 million of these motors, and even if I only sold that model to one OEM, that OEM could program that model
Completely
motor
differently.
5 different ways
Absolutely.
for their fossil fuel 80, fossil fuel 90, air handler package system.
Right.
So you have to order it by the model number of the appliance and get it from the manufacturer if you're going to replace with an OEM motor. Now, earlier we said, well, and I admitted, technicians have told me, well, I took a 2.5 that, out of a train that we replaced the whole unit, and we knew the motor was good, and I left it in the truck as my emergency motor, and I plugged it into a Lennox. There's probably people that work for all these manufacturers
Oh yeah,
that are
absolutely.
cringing every
Used to.
time I say
Yeah.
the words, and it ran.
Yeah.
And so I proved that all ECMs are the same. You're lying to us. And well, you got lucky. One, that it even ran, that it was using the same communication style.
Right.
But I guarantee the dip switches, no matter what they were set to, were
It's
not producing
unknown.
the airflow you need. It's
Absolutely.
completely unknown.
Completely
Exactly.
guessing.
Exactly. So have to go OEM if you're going to replace OEM. However, there's been a very big development in the last 5 years, and that's the
Mm-hmm.
introduction of retrofit universal replacements for variable speed motors.
Sure.
And with everything I've said to this point so far, if I'm in the audience, I'm thinking, well, that's not possible. These are all uniquely programmed. How could you possibly do that? And the way we did it is, for the 4-pin motors, remember I said earlier, the 4-pin serial communicated motor is a slave to the OEM board. It does whatever the board says.
Yep.
So our 4-pin universal Evergreen VS just takes the place of the slave that was there before. Uses the same communication style, no problem. In the 16-pin motors, we use a device called a user interface.
Yeah.
And so we can't possibly know how 20 million motors were programmed, so we don't even try. We simply move all the airflow adjustments to this box.
So you can manually control it.
You can set the airflow on this box, and
Sure.
so that the technician that's always done things the right way, has always set the dip switches, is going to throw that argument. Well, now I have to set the airflow here. I know I set it up perfectly on this system because I installed this system 10 years ago, and now I have to do this again. Well, yes, that is true.
Absolutely.
But the challenge that we have with replacing these motors from the OEM is sometimes they're not in stock because they have so many to stock, right? One OEM may have 50 to 100 different uniquely programmed motors to keep in stock in 3rd, half, 3/4, and 1 horsepower, and different voltages.
Different voltages.
We do make, well, this is dual voltage, but we do also make it 277. So they have a lot of motors to stock. It may not be in stock. The cost of that motor may be prohibitive to the customer. And if it's not in stock, it may not be available in a day or two. It could be a week or two.
Exactly.
Right? So think about that. If you're the contractor that put this system in, you're going to tell your best customer. How do I know they're your best customer? Because they spent big bucks on the premium system.
Absolutely.
You're going to tell them, I'm sorry, even though you bought a BMW, I can't give you your car back to you for 2 weeks. That's not going to fly.
Not going to fly, is it? Yeah.
So with Evergreen, you can have an off-the-shelf alternative. Will you have to adjust the airflow? Yes. We did set defaults in the UI. We set default airflow for 1st and 2nd stage. We set default on and off delays so that
it would be
as close as possible. But just like the defaults in the OEM systems, you still need to go in and set the airflow. So I get asked, is it pre-programmed? Yes. Will I have to do some setup? Yes, just like any system. I can't guarantee it's not going to need, one of the airflow tweaked a little bit.
Yeah.
Right.
Man, that's a dandy.
But it is going to allow the technician to complete the job the same day. And it's possible, likely, that the cost of the universal replacement will come in equal to or under the cost of the OEM motor.
Yeah, absolutely.
So I'd also want to mention that the user interface you're seeing on the screen was our 1st generation. We're actually in our 2nd generation now.
With mobile.
I'm going to go backwards 1 slide so you can see the difference. So there you've got all your airflow and delays and options and lights. And on the new one, we took everything away and only gave you 2 buttons. And there's a really smart reason I did that. And that is because technicians like easy things.
Oh, yeah.
And I even have to admit, when I see something that's got a lot of lights and a lot of buttons, my brain immediately starts to blue screen. And for those of you that have never owned old computers, you don't know
that's a VCR right there in front of me.
Means, right? But ultimately, what any technician is going to have to set is the airflow, right? I've set the on-off delays already. They probably won't have to adjust the delays, but they will have to adjust airflow. So those are the only buttons we left on there. And then we put everything else in the app. And here's the really cool thing. With the app, I can install the UI in the system, put the door on, turn it on,
and
let
watch
it get
it with
to
the
steady
door
state
on.
condition.
Yeah.
And I can look at my thermometers. I can go in the app and I can adjust airflow real time in the app. I can make the motor go faster or slower while it's running in the system. So no, hey, my temperature rise is just a hair too high. Turn it off, take the doors off, adjust doors on, turn it on, wait for steady state. Hope I got it. I can do it all in real time. Yeah. So we moved the functions that the technicians that want to really tune it in to the app, we made them more user-friendly so that they can reduce their time on the job if they choose to do that. But I'm also hoping it encourages technicians that didn't check airflow before because of the time excuse.
Absolutely.
Right? Can't solve the tool excuse because you're always going to need the tools for either measuring air or temperature. But I can reduce the time excuse by having a device that allows you to adjust it in real time.
Yeah, absolutely. While that thing's ramping up, you can be picking up tools and getting things organized and make your final adjustments, or pick up and clean up some more and then recheck it again. Yeah, that's a fantastic way to look at that. And Bluetooth and different communicating technologies are the direction that we're heading with all of our equipment. So it makes
Yeah,
complete sense to have a replacement part that is that much more convenient. No, that is
yeah.
really good. One question did come in a little bit ago from Todd. What about rewiring through different generations of motors there?
Rewiring the
Yeah,
Evergreen.
like from a 16 pin, is it just a single plug connection? Because if we are changing plugs between
Oh,
the
I see what
different
you're saying.
generations.
Yeah, sorry. I didn't put, I knew we only had an hour, so I didn't put
Yeah.
the whole Evergreen VS installation process in here. But what you can't see in the right-hand side of the user interface is a
Hmm.
16-pin plug in.
Ah, gotcha.
So you take the 16-pin plug from the old 2023 Eon motor
Yep.
and you plug it into the side of the user interface, and then the user interface has the 4-pin out that plugs into the
Into the new
new
motor.
4-pin motor. So
Nice.
we did that because it was easier to do. So you've got the 3.0 with the 4-pin, and you've got all the other motors with the 16-pin.
Hmm.
It was easier to replace all of them with a 4-pin motor that we converted over than a
Sure.
16-pin motor that we went backwards in technology.
Absolutely.
So we
Going
took,
forward, that's the
yeah,
new model. I mean, everyone's going to be using
yeah. So we
that.
took the most recent technology. So,
Yeah.
and because we talked about it earlier, and you asked the question, which I greatly appreciate, because it gives me an opportunity to talk more. If you're doing 2023 or Eon,
Yeah.
you'd use the user interface and the motor. If you're doing 2.5, you would just use it. It's a little 16 to 4-pin adapter, actually
Oh,
the same
okay.
one we sell for the TechMate
Yeah.
Pro.
Right.
You would only need that because it's actually a serial communicating motor.
Yeah.
It just has a 16-pin
Just needs to
plug.
be repinned. Yeah.
So 2.5 would use the motor only with
Okay.
just a little 16 to 4-pin adapter. It would not use the UI. And then 3.0, oops, sorry. And then
3.0 is just
3.0 would
motor.
use the just the motor only.
Yeah.
And we
Nice.
do now sell this for anyone that's familiar with this or used one before. We started out by selling the motor and the UI separately. We now
Hmm.
sell the motor and the UI all in one box.
Okay.
So with if you buy that one box, you're going to cover every motor except 2.5 with just that one box. And I do get asked, well, why didn't you throw the 16 to 4-pin adapter in the box? Well, it's actually about a $4 part.
You're
You
right.
look at it, where's all this money? But it's in the plastic plugs.
Absolutely. Custom
And
molding.
so if you look at 2023 Eon and 3.0, we built approximately 20 million of those over the lifetime, right? We built about 20,000 2.5. And I'm
Yeah.
not good at math, but that's in the
Right.
0.00.
That's a lot of $4 parts going in the trash that shouldn't.
Exactly. So
Yeah.
that's the only reason we chose not to put it in there.
Sure.
I mean, honestly, it was an economic reason,
Hmm.
but it's an eco reason as well. That's a
Yeah,
lot of plastic
absolutely. That's a
going in
lot
the
of
garbage that
throwaway.
just doesn't make sense. So
Yeah.
we decided not to put that in the box for that reason.
Wow, that's a lot of deep diving into motors. And we want to make sure for those who still have unanswered questions, where to dive even deeper. I know we still got some more content to go over, but I want to make sure you know your resources. So this is we're getting us down closer to understanding, and you want to dive further. We highly encourage you hopping over to Motor Mastery University, where you can get further courses on each of these components and get more specific training. But now we at least know how these things operate and how easy they are to actually test.
Absolutely. And thank you for the plug. We've done a lot of hard work to make that university all encompassing and very easy to get to.
Absolutely. I
So
think that
yeah, I
was,
just have a couple more slides left.
yeah.
I mentioned our app, so that the app, the tool for the Evergreen VS motor is called the Evergreen VS Optimizer. It's actually in our dealer tool belt app, which is a
Hmm.
free app.
Nice.
And in there, you can find, if you're going to use Evergreen, for example, you can find a cross-reference tool to cross your motors for you.
Your
So
original. Yeah.
yep. So you simply open up that tool, plug in your model number, and it'll tell you exactly what Evergreen you need to use. So you don't have to
Nice.
use a complicated cross-reference. There's a lot of different motors that we replace. Do I need the UI? Do I need the adapter? You simply go in there, plug your number in, and it does it for you. A lot of the diagnostics that we talked about here today are actually included in that app, so you can reference them on your phone. There's even some videos in there.
Hmm.
Distributor locator, if you don't know where your closest distributor is, and some induction motor replacement as well.
Nice. That's
The
a lot of goodies.
There's a lot of goodies, and I'm going to go
Yeah.
through them a little quickly, but if you want to stop me, go ahead. But I know we're already over on time.
No, that's okay.
Motor Mastery that you mentioned, you have
Yep.
access to the Motor Mastery University right in the app. So
Oh,
if you're
I
in your
missed
truck,
that. Okay,
yep,
cool.
if you're in your truck and you want to watch one of my podcasts,
Yep.
if you want to
Yeah.
watch one of my monthly motor minutes,
Mm-hmm.
you can simply open up your app, and within a couple of touches, you're training.
There you go. You're becoming a motor master with the Motor Master.
Yeah, I hope so. Someone needs to take my place soon. I mentioned the Evergreen VS tool, and the one that I think it really for tech. I mean, you know, technicians. Every time a technician watches a show, podcast, whatever, we have an app. Oh, another app I got to put on my phone.
Right.
In this app, if you're going to install Evergreen motors, this Evergreen Tech Support button's your new best friend. Now, the manual comes in the box, right? But manuals get lost, you know, so the runner takes the box out to the job, somebody starts to install it, the manual, whatever. You don't have the manual. You click on that button and you will see Evergreen EM, VS, IM, OM, the four Evergreens we have.
Models. Yeah.
You touch the one you want, and the first thing you see at the top of the screen is click here to give me the manual.
Oh, wow.
If you scroll down a little further, and I didn't animate this, but if you scroll down a little further, click here to watch a video on how to install this motor. So
look at you.
We built this. Well, I built this, and Regal-Rexnord said, "Okay, we'll let you put it on our app."
Yeah, how about that?
I want this. I'm a tech.
Yeah,
I don't want to wade through brochures. I don't want to start at Regal-Rexnord and drill all the way down to where.
Yeah,
I want to touch a button.
I want
and
the
get
hot
to a
button.
Manual. Yeah, I want the hot button. There you go. So this is doesn't have the bat sign, but I want the hot button for Evergreen. That's exactly what we built there, and I'm very proud of that as a former technician.
As you should be.
Yeah. So all of that is mirrored on the internet. If you like to use your computer, if you're a counter personnel, or you're just you do a lot of your training at home on the weekends, it's the Dealer Tool box on the website. It's the Dealer Tool belt on your app on your smartphone.
I like that.
But everything is mirrored there. The resource center, the Evergreen Tech Support, the distributor locator, the cross reference, everything that's in the app is on the site, and vice versa.
All right.
And I'm going to wrap it up unless you have more questions or our audience has more questions. I'm going to throw my email up there. And I do want to give one more shameless plug for our training site, which is regalmmu.com. You already put up that wonderful QR code for them to click on. One thing we started, you can see all the stuff that's in there, the literature, the videos, the online learning, but articles, but podcasts. One thing we started 2 years ago is a tech tip. And, everybody's done a tech tip. And I'm ashamed to say I didn't come up with this idea. I copied somebody else, but I saw somebody else doing video tech tips. And I thought, well, that's a great idea.
Yeah, video shorts.
Everybody just wants to scroll through Facebook or whatever and watch that thing for a couple of minutes and go on with their lives.
Right.
So I've been doing monthly tech tips. Sometimes it's on a product that just came out. Sometimes it's how to connect the wires, how to use the Tech Inspect. But there's monthly tech tips in there. If you go in and sign up, we will send them to you every month automatically. You don't have to go in and look for them. But there are also now, I believe, over 2 years worth of tech tips in there.
Yeah, there's got to be quite a bit by now.
So it's like, it's not as cool as binge watching Yellowstone, but you can go in and you can binge watch my.
You can keep going for a while.
Motor Minutes, absolutely. So a lot of good stuff in there. I do also want to mention, if you didn't notice the logo, we do own the brand Century, which is formerly A.O. Smith and Fasco. So a lot of that old literature and videos are in there as well. If you remember the old Fasco Facts.
Heck yeah.
Fasco Facts used to be the induction motor Bible. To me, it still is. It's a PDF. It's a free PDF in that literature library in there. So a lot of really good stuff in there. Go poke around, have some fun. And one last shameless plug. I did write a book a while back. If you are really a motorhead, you really want to know the stuff that we left off at 100,000 feet. We said, you want to go all the way down to ground level on these things.
Yeah.
I wrote a book. It's available at ESCO.
Absolutely.
I do want to say
in the library.
Yep. If you're an instructor with a trade school, please tell them that. They may give you I think it's called a desk copy, a free or discounted copy for you to review to maybe use for your students later. But I wrote it from the viewpoint of a technician. What does a technician need to know about these motors? Now,
Yeah.
I did go deeper into the engineering information, but I wrote it the way a technician would understand it, not the way an engineer would speak it.
Right.
And tried to always to correlate the information to something that would have value to you in the field. So a good book, I think it's only like $40. Good book if you're interested in being that, that complete motorhead on ECM.
I'll have to grab that one. I have not read that one myself, so that one will be on my agenda. Yeah, I can see you're probably we probably think a lot alike. We like to read the details and rewrite them with crayons.
Yes, as much as possible.
Absolutely. Bring it down to our technician perspectives. It's not that it's a reduced version. It's just reiterated with a different perspective.
Yeah, and I love the way you said that, and it's the first time I've heard somebody else say that it made me think of something. I say that all the time. Bring it down to our level, and I don't want anyone listening now or watching the recording later to think that we have to bring things down to a technician's level. We are experts in our field, and we work on some very sophisticated stuff. When I say that, or when Clifton says that, I think he means what I'm about to say, and that is we're going to bring it from the engineering speaker, the engineering level, the blueprint level, down to what we need to know to get the job done in the field. Not necessarily bringing it down because we're not well-educated and well-rounded technicians, just we need to bring it down to that speak that makes sense in our world.
Absolutely. It's not a vertical translation, it's a horizontal translation.
Thank you. I wanted to make sure that no one misunderstood that.
Absolutely. Wow, that is some super good stuff, Chris. We still have quite a few people out there in the audience. Anyone have any questions that they would like to grab from Chris? And also want to make sure, one of the important parts about these conversations, these shows, is that we bring the most qualified people from the industry to hang out here with you, to talk about opportunities, to talk about training, to talk about being better together. And so not only one, but there will be 2 classes at the National HVACR Education Conference brought to you by Regal-Rexnord, one of which will be Chris Mohalley. So if you want to hang out at the conference with us, come on by. We'd love to talk to you. This is a big event for all of us. And so we really look forward to seeing you at the conference.
Yeah, and we do a booth there too. I hope I didn't cut you off. We do a booth at the trade show, and I love it when you guys come and gals come and tell me your stories, tell me what did work, what didn't work, or something that I've never thought of. So please, even if you don't have a need to come to the booth for something, please just come by and say hi and talk motors with me.
I love it.
Or cars,
or cars. Well, you're hard telling what you'll catch us talking about.
Howard wants to talk about tillers next time, I guess.
That's not like it. All right, everyone. Well, thank you so much for joining episode 1 of a 4-part series. Next month, we're going to be diving into constant torque motors. And you're going to go, wait a minute, did we just talk about ECMs? And we'll go, no, we're going to talk about their cousins, the constant torque versions of those.
Yes, we are.
All right. Well, thank you so much, Mr. Mohalley. And we look forward to seeing all of you again next week on Did You Know the ESCO HVAC Show? Tell all of your friends about the great stuff that we're doing over here. Subscribe to the channel, turn on notifications. That way you can join us for these live conversations with the coolest educators you have ever met in your life.
I've never been called that, but thank you.
Absolutely. All right. Bye, everybody.
Thank you.